Short video will explain how to define a user-defined function in R. R has many built-in functions. For instance, here's the exponential function. And for most functions, you have a name, a parenthesis, an argument, and an end parenthesis. E cubed. We have logarithms. We have trig functions. Often with trig functions and in other areas, we might want to represent pi, and R actually has a built-in constant called small pi, and basically it's pi to as many decimal places as the precision of R will allow. It's actually more than you see here. Square root, most people have seen these before. And here's a built-in operation, exponentiation, 5 to the 7th power. But suppose you want to deal with a function that's not built in. How do you do that in R? Well, the simplest thing to do, and remember, because of the way R's help works, you'd actually have to, notice I did question mark function. I had to put quotes around it. I was getting an error when I didn't. You get a little thing that says to define a function, argument list. This is actually the expr is an expression which will define the function, and the optional return value. And then the usual definitions. Let's actually see how this works. So suppose I want to find a function or define a function that will let me find the area of a circle given the radius. Well, remember that's pi r squared. It's as simple as this. Name of the function is C underline area. And notice no parentheses when you're naming the function. Assignment operator. The word function. The argument, in this case r for radius, though this is really a dummy variable, pi times r squared. Now let me actually find, let's do C underline area 7. 153.98. What I usually do, even for short functions like this, is my definition is going to look a little different. Notice the braces. Now, the braces are not necessary if you could fit the definition of the function on one line. But if it takes multiple lines, you actually need them. Now, here's an example of where you do need it. So I'm going to just define some function called long fun. And now look what it is. It's long function x, same thing, brace. And then the argument says I'm within the definition, I'm defining a variable y, 3 times x, which suppose x was 1, this would be 3. Then z is y plus 7. In this case, it would be 3 plus 7, 10. T is z squared. 10 squared is 100. And this will display t. Let's actually see what happens. Let's do long fun 1. There it is. There's my 100. Notice I haven't used the word return. Most of my functions, I don't use the word return because the last part of my defined functions usually are what I want to return. However, you could explicitly put this in. So here's an interesting function called retfun. I just made it up. Argument, braces x squared, and it's a return. In this case, it's going to return a vector, x squared and 3 times x. I could have done this without the return also. And notice here my vector is actually returned. User-defined functions can actually have several arguments. Almost everything that you can do in algebra, you could do in R. So look at this function. It says arg2, word function, 2 arguments x and y. And the definition, 3x squared plus 4y squared, arg1, 2, there you get 19. 3 times 1 squared plus 4 times 2 squared is 3 plus 16, or 19. Let me erase the screen here for a second. And now let me show you. I find this function a lot of fun, actually. And we'll see what we can do with it. Okay, in this case, I'm defining a function called toss k. And notice function, the argument is k, and it uses the sample function. And I'm going to have to find a variable heads, and that sample, what this is going to do, is going to sample from the vector 1, 0, k times. Replace equals true means I'm doing this without replacement. Actually, with replacement, again and again and again and again. And it's going to actually return the vector. Basically, each time you get a head or a 1, you'll put in a 1. Each time you don't, you get a 0. Add up all the heads and divide by k, or I could have just used mean heads for this. And that gives me the mean value, or the average number of heads. 0.46. This is actually the proportion of heads in 50 tosses. One nice aspect of this particular definition is if I wanted 100 tosses, I could just use toss k 100. Now, why is this nice? Well, this could be any number of complex operations, but look at this next thing. R has a function called replicate built into it. And all this says is look at toss k50 and replicate it 1,000 times. So I'll actually have 1,000 proportions, averaging around 50%, but there'll be all sorts of different things. As a matter of fact, let me type SAM. There they are. Not too interesting looking at these. Here's a 60, here's a 44, but I can actually use a histogram on this. And lo and behold, what I'm getting is the estimated sampling distribution of the mean of 50 tosses of a coin. The reason the code was so short was because I had this nice definition of a function. You can do lots of things with functions in R, and that's the end of this video on user-defined functions in R.